The framework simulates the seamless physical behavior of continuous fields and particle dynamics interacting with a sharp, two-dimensional slit barrier by mapping the coordinate space into a confocal elliptic curvilinear coordinate system. Rather than resolving boundaries through fragmented Cartesian step functions, which create computational instabilities and artificial numerical noise at abrupt geometric transitions, this mathematical architecture treats the rigid barrier as a single, uniform parameter boundary. Across three specialized modalities, the visualizer maps geometric coordinate grids, calculates real-time analytical wave diffraction fronts that bend continuously around the plate without internal edge stitching, and drives a Lagrangian fluid streamline simulation whose particles accelerate smoothly through high vorticity regions near the singular focal tips. By linking an interactive profiler directly to the curvilinear transformation equations, the system dynamically calculates the local area magnification factor in real time, demonstrating how a specialized coordinate mesh can preserve mathematical calculus and guarantee spatial stability across complex boundary value problems.